Alright, in this video we're going to look at inverse variation. So these statements are equivalent. Y varies inversely as x and y is inversely proportional to x. Okay, so if they tell you either one of these, then your equation is going to be y equals k over x, and k is some non-zero constant. Okay, so let's go ahead and look at some examples. I'm going to do two examples. One's going to be a simple one. The first one will be just kind of to show you how to solve for k, because that's the main thing that we need to do. We need to figure out what k is, our constant. And then I'll do a word problem. Alright, so let's take a look at our first example. Alright, so here they want us to find a mathematical model representing y varies inversely as x. Okay, and that's when y is equal to 3 when x is equal to 25. Alright, so first let's go ahead and get our equation. Okay, so y varies inversely as x, so that means y equals k over x. And now what we need to do is figure out what k is. Well, they're telling us that y is 3. Okay, so we replace the y with a 3 when x is 25. So that's going to be k over, and x is 25. And then we solve for k. So to solve for k, we'll multiply both sides by 25. And so that's going to give me k, see the 25's cancel, is equal to 75. So my equation is y equals 25 over x. And there's my equation. And another way that you could write this is y equals 25 times 1 over x. Okay, you could write it like that too. Might be easier if you just leave it like this. Alright, so that's the main thing, figuring out what k is. You got to have the information so you can figure out k. Alright, so let's take a look at the word problem. Alright, so here's our word problem. It says a gas law states that the volume of an enclosed gas varies directly as the temperature and inversely as the pressure. Okay, so we've got two things going on. It varies directly and inversely. Okay, so I have a video on varies directly. You can check that out. But basically, if let's say y varies directly as x, well, that just means y equals k times x. That's direct variation. Okay, and I've got a whole video on that. You can check it out. Okay, so basically what we're going to have to do in this problem is we're going to have to combine the two, varies directly and varies inversely. Alright, so let's see. The gas law states that the volume, okay, so we're gonna let the volume be V, okay, of an enclosed gas varies directly as the temperature, we'll call the temperature T, and inversely as the pressure, so we're going to call the pressure P. Okay, so let's go ahead and set up our equation. So it says the volume varies directly as the temperature, so that's going to be K times T, because for direct variation it's multiplication, and inversely as the pressure, so that's divided by the pressure P. Okay, you remember that from here, see, K over whatever this variable is, and in this case it's P. Alright, so let's go back to our example. Alright, so we have our equation. Now we need to figure out what K is. Okay, so let's look at the information they give us. So it tells us that the pressure of a gas is 0.75 kilograms per square centimeter when the temperature is 294 Kelvin and the volume is 8,000 cubic centimeters. Okay, all right, so let's start plugging these numbers in. All right, so we know this is V, okay, here's P, the pressure, and here's the temperature, T. Okay, all right, so we have 8,000 is equal to K times T, which in this case is 294, over P, the pressure, which is 0.75. Okay, so we get 8,000 is equal to, now what I'm going to do is I'm going to go ahead and divide this in my calculator. So I have 294 divided by 0.75, and that is 392. That's what this is when I divide this in my calculator, and that's times K. So I divide by 392. I've got to figure out what K is. So K is, let's see, okay, it comes out to a long decimal. I'm going to just put 20, I'm going to round it to 1 decimal place. Okay. The actual answer is 20.40816,327. You might want to use all the decimals and round at the end, but for the sake of the video, I'm gonna round to 1 decimal place here. All right, so now my equation is V is equal to 20.4 T over P. Okay, so there's my equation. Now let's see what they're asking us to find. Okay, this is what they're asking us to find. See, this part right here is the information, the stuff in red, that's the information they gave us so we could solve for K. And then the stuff underlined in green, this is what they're asking us to find. Find the pressure when the temperature is 300 Kelvin and the volume is 7,000 cubic centimeters. All right, so here you can see they give us the temperature T and the volume, and we need to solve for P. All right, so let's go ahead and do that. So we've got 7,000 is equal to 20.4 times, and then the temperature is 300, and that's over P. So we need to solve for P. All right, so we can look at that as a proportion. Well, I think what I'll do first, before I do anything, I'll go ahead and multiply this out. So I get 20.4 times 300, that's 6120 over P. Okay, now look at it as a proportion. We can cross multiply, and so that's 7,000 P equals 6120. Divide by 7,000, and so I get P is, and I'm going to round it to 2 decimals, that's 0.87, and let's see, and that's the pressure, and that's in kilograms per square centimeters. So that's kilograms per square centimeter. And there's your answer. Alright, so I hope this video helped, and like I said, for the direct variation, you can check that video out. And give me a like and subscribe and share the video. Thanks for watching.